Subscribe now.
Hello my dear children. Since the board examination of 2025 is approaching, we are going to cover today the numericals of chapter solution from grade 12 CBSE. As you know that this chapter is a chapter of physical chemistry, we got a lot of numericals. So I'll try to cover all the PYQs of solution chapter. My name is Arpita Banerjee and you are watching Arpita classes. Let's get started. The first question is a non-volatile solute X which has a molar mass of 50 gram per mole when dissolved in 78 gram of benzene reduce its vapor pressure to 90%. Calculate the mass of X dissolved in the solution. This question has come in 2023 and it was of 2 marks. So first of all, we have to write all the information given in the question with proper denotation. Okay, we all know that solute, the information of solute is denoted by B and the information of solvent is denoted by A. I'll remind you everything while doing the sum. So first is a non-volatile solute X. The solute is X over here which is having molar mass 50 gram per mole. So molar mass is denoted by capital M, and since it is solute, so either you can write MB or you can write M2, whatever it is, okay. So I wrote MB, this is 50 gram per mole, this is the first information which is given to us. When dissolved in 78 gram of benzene, so 78 gram is the weight of the solvent. So weight of the solvent is denoted by WA, which is 78 gram, okay. Reduce its vapor pressure to 90%. So the vapor pressure, the original vapor pressure will consider as 100 and it is reduced to 90%, okay. So we'll write down the vapor pressure of original benzene, that is P0 A you can consider, which is 100 millimeter of Hg, and now the vapor pressure of the solution which is denoted by Pa, which is 90 millimeter of Hg. Reduced to 90% means the new vapor pressure of the solution is 90 millimeter of Hg. Okay, when it is given in percentage, we can take it as 100 and this way. Okay, calculate the mass of X dissolved in the solution. They are asking for WB is what? Okay, and also we know since the solution solvent is benzene over here, the molecular mass of benzene, that is Ma, will be is equal to 78 gram per mole. I told you to remember the molecular masses of benzene, which is 78, glucose which is 180, and cane sugar which is 342. If you remember the molecular masses, it will be easy for you. You don't have to calculate. Okay. So now we have the formula, that is, we'll first write down the formula. We have written all the information given. Now we are going to write down the formula. The formula is P0A minus PA upon P0A. What is it? It is your relative lowering of vapor pressure, which is equal to, we know, X2, right? And what is X2? X2 is the molar mass of the solute. XB I should write because I am denoting by A and B. So I will be writing XB, and XB is what? It is a mole fraction of the solute. Now mole fraction of the solute is nothing but NB divided by NA plus NB. I am writing the entire thing so that you understand how come the formula is coming. Now since it is, we are considering as dilute, here all the questions will be of dilute solution. Therefore, from Na plus Nb, we can just write down Na. Nb is very small, so we can neglect it. Okay, so this will be is equal to Nb divided by only Na, because Na plus Nb will be equal to Na. Why? Because Nb is very small as compared to Na. Okay, I am showing you the derivation also, which will help you in theory part. So now Nb and Na. Nb is a number of moles of solute. Na is a number of moles of solution. So we got it here, that is P0A minus Pa upon P0A is equal to NB upon NA. This we got. Okay. Now in place of NB we can write it down as WB upon MB. Number of moles is equal to weight upon molar mass. Okay, and Na is WA upon MA. So when we calculate this, we get WB upon MB into MA upon WA. So the final formula becomes P naught A minus PA upon P naught A will be is equal to WB into MA upon MB into WA. Now we have all the values. P naught A we have taken as 100 minus PA is 90 divided by P naught A is again 100 is equal to WB, which we have to find out. We have to find out the weight of the solute into molecular mass of benzene, that is 78, divided by molecular mass of the solute, which is given to us, I guess, 50 gram per mole. This is given to us, so we'll put 50 over here into WA, which is your weight of benzene, which is again given to us. WA is 78. So I'll put 78 over here. So now 78 and 78 will get cancelled. We'll calculate this. This is coming 10 upon 100 is equal to WB upon 50. So 0 and 0 gets cancelled. So now cross multiply. 10 WB is equal to 10 into WB is equal to 50. Therefore WB is equal to 50 upon 10. Therefore WB is equal to 5 gram. So the weight of the solute here is 5 gram. Okay, I could have used the formula directly, but since I wanted to show you how the formula has come, that is P naught A minus P upon P naught A. What is the formula we have used over here? That is P naught A minus PA upon P naught A is equal to WB into MA divided by WA into MB. This is the formula we have used over here, but I told you how the formula has come. So that will be used in case of theory also. And if you by any chance you forget the formula, you can derive the formula from here. Okay. So first we have written all the information which is given in the question. So these are all given. Okay. Then we wrote the formula. I told you, I showed you how to derive the formula also. We came up to here and then we have put all the values and finally we got the answer along with the unit. So now we will proceed with the next question. The next question is calculate the solubility of carbon dioxide in water at 298 Kelvin under 760 mm Hg. Kh is given to you, that is 1.25 into 10 to the power 6 mm Hg. And this question has come in 2020 for 2 marks. So here we can understand when Kh is given, that means it is a question from Henry's law constant. So first we'll write down what is given to us, that is Kh is given to us. Kh is equal to 1.25 into 10 to the power 6 millimeter of Hg, and the pressure P is equal to given, that is 760 millimeter of Hg. Both of them are in the same unit, so we don't have to convert anything. We know the formula, that is Kh is equal to P is equal to Kh into X. P is equal to Kh into X. This is the formula, where X is what? X is a mole fraction of CO2 here. Okay. So now P is given 760, so we'll put 760 over here, and Kh is 1.25 into 10 to the power 6 into X. So the value of X will be 760 divided by 1.25 into 10 to the power 6. This will be the value of X. Will not calculate. I have the calculation with me. I'll just write the value from the calculation what I have, because calculation will be hectic. So I'll just write down the value. Okay. So Kx is equal to, we have 6.08 into 10 to the power minus 4. So we'll write 6.08 into 10 to the power minus 4. This is the value of X, that is mole fraction of carbon dioxide. We have been asked the solubility of carbon dioxide. Solubility is denoted in number of moles. Okay, so from mole fraction we have to convert into number of moles. So X of CO2, I'm just writing it this way, is equal to N of CO2 divided by n of CO2 plus n of water. Number of mole fraction is equal to what? Number of moles of that particular component divided by total number of moles of all the components. Now here, if nothing is given, we have to consider the volume of water is 1 liter. Okay, so volume of water is equal to 1 liter, and 1 liter is almost equal to 1 kg. Almost equal to 1 kg. Okay, because we know the density of water is 1 kg per meter cube. So according to that, it is 1 liter is 1 kg. 1 kg is equal to 1000 gram, and from there we can get the number of moles of water, that is 1000 divided by molar mass of water, which is 18. So it will come 55.5 moles. Okay, so it is almost equal to 55.5 moles of water. Now here it is, we know that we are talking about dilute solution. All the questions are of dilute solution. So from the denominator NH2O plus NCO2, we can neglect the value of NCO2 because this is very small value. So we can write it down as NCO2 divided by NH2O. Why? Because NH2O is very much greater than NCO2. So we neglected the value of NCO2. Okay, so finally we got XCO2 is equal to NCO2 by NH2O. So we got XCO2, mole fraction of CO2 is equal to N of CO2 divided by N of water. So N of CO2 will be is equal to X of CO2 into N of H2O. Now X of CO2, how much we got? We'll just see the value of X of CO2, which is 6.08 into 10 raised to power minus 4. Okay, so we'll write it 6.08 into 10 raised to power 4 minus 4, I guess. Just a minute. It is 10 raised to power minus 4, yes. 10 raised to power minus 4 into 55.5. So you just multiply this and this, 3.375 into 10 raised to power minus 2. Yeah, so this is the number of moles of CO2. That is the solubility. We'll now see the next question. The next question is 30 gram of urea. 30 gram of urea, which is having molar mass 60 gram per mole, is dissolved in 846 gram of water. So by seeing the weight, you understand that urea is a solute and water is a solvent. Okay. So 30 gram is denoted by WB, is the weight of urea, which is 30 gram, and molar mass of urea, which is 60 gram per mole. This is dissolved in 846 gram of water, which is my weight of solvent, that is 846 gram of water. Calculate the vapor pressure of water for this solution if vapor pressure of water at 98 Kelvin is 23.8 millimeter of Ag. This is vapor pressure of water, which is denoted as P naught A, pure vapor pressure of water, that is 23.8 millimeter of Ag. We need to find out the vapor pressure of the solution, that is PA we have to find out. Okay, and this question has come in 2017 and it was of 3 marks. Okay, so we'll apply the formula again. Now I am directly writing the formula. In the first question I already told you how to derive the formula. So now directly formula is P naught A minus PA upon P naught A is equal to WB into MA divided by WA into MB. This is the formula. We'll put all the values. P naught A is 23.8 minus PA divided by again P naught A 23.8, WB which is 30, MA. Now this is water, the solvent is water, so MA is 18 divided by WA is 846 and MB is 60. So now you can calculate from here, 0 0 cancel, 3, this is 2, this is 9, 9 and this will go by 3, so 3 3, 3 2 6, 3 8, 3 2 again, and they again go by 3 3, 3 9, 3 4, 94. So it is coming 23.8 minus PA upon 23.8 is equal to 1 upon 94. Now we have to just cross multiply this. So it will be 94 into 23.8 minus PA will be is equal to 23.8. So this is 94 into 23.8 minus 94 into PA will be is equal to 23.8. So minus 94 PA is equal to 23.8 minus 94 into 23.8. Now here you can take from the right hand side, we can take 23.8 common. So if I take 23.8 common, I will get 1 minus 94 here. That is minus 93 into 23.8. So here minus and minus will get cancelled. So finally PA will be is equal to 93 into 23.8 divided by 94. So the answer is 23.54 millimeter of Hg. Yes, so this is the answer for this question. Let's start with the next question. Question number 4. It has come in 2023 for 2 marks. The vapor pressure of pure liquid X and pure liquid Y at 25 degrees Celsius are 120 millimeter of Hg and 160 millimeter of Hg respectively. It's okay. So vapor pressure of pure liquid X, that is P naught X, is equal to 120 millimeter of Hg. First you have to write down the given information. So I am writing here the given information, and P naught Y is equal to 160 millimeter of Hg. These two things are given to us. Okay. If equal moles of X and Y are mixed to form an ideal solution, equal moles means Nx is equal to half mole, and even Ny also equal to half mole, because total number of moles will be 1. So equal mole means half mole and half mole are mixed to form an ideal solution. Calculate vapor pressure of the solution. So we have to find out the vapor pressure of the solution, that is P. So we know that according to Dalton's law, total vapor pressure PT, I'll write it down as PT, that is the total pressure of the solution. PT is equal to partial pressure of X plus partial pressure of Y. This is Dalton's law. Now according to Raoult's law, okay, partial pressure of X is equal to pure vapor pressure of X into mole fraction of X. This is according to Raoult's law. Okay, similarly partial pressure of Y is equal to pure vapor pressure of Y into mole fraction of Y. This we know already. Okay, this is as per Raoult's law. So we'll put Px and Py's value in equation number. This is equation number 1, suppose. Putting these two values, or you can write down this is 2, this is 3. So you can write down now from 1, 2 and 3. From 1, 2 and 3. Pt is equal to P naught X XX plus P naught Y XY. Right? So now P naught X is how much? P naught X is 120 and XX is Nx divided by Nx plus Ny. Okay, I'll just do it here so that you understand. Xx is equal to Nx divided by Nx plus Ny. So now Nx is half and Nx plus Ny is again half plus half. That is, it is half divided by 1. So it will be half only. Okay. So I'll put it here, 120 into half plus this will be 160 into, even xy will come half. So it is coming, this is cancelled 60 and this is also cancelled 80. So it is coming 60 plus 80, that is 140 millimeter of Hg. So the entire pressure of the solution is 140 millimeter of Hg. So now question number 5 says, calculate the mass of compound, molar mass is 256 gram per mole, to be dissolved in 75 gram of benzene to lower its freezing point by 0.48 Kelvin. Kf for benzene is given, that is 5.12 Kelvin kg per mole. Question has come in 2014 for 2 marks. Okay. So let's write down the given information. Given information first is calculate the mass of the compound. So this is a solute and they are asking for mass, that is Wb. Molar mass, that is Mb, is equal to 256 gram per mole. To be dissolved in 75 gram of benzene. So your Wa, weight of solvent, is 75 gram and molar mass of solvent will be 78 gram per mole. For benzene it is 78 gram per mole. Okay. To lower its freezing point by 0.48 Kelvin. So delta Tf, depression in freezing point, is 0.48 Kelvin. The value of Kf is given, that is 5.12 Kelvin kg per mole. Okay. So we know that the formula here is, first we'll write down the formula. Formula is equal to delta Tf is equal to Kf into molality of the solution. Let's break molality. What is molality? Molality is equal to number of moles of solute divided by weight of solvent in kg. Okay. So we write down delta Tf is equal to Kf into, okay, number of moles of solute Nb can be written as Wb divided by Mb into Wa in kg, means Wa upon 1000, and that 1000 will go up. Okay, because we know that by default in chemistry all the weights are given in grams, so we need to convert Wa in kg, so we will divide it by 1000. So the formula finally we get delta Tf is equal to 1000 into Kf into Wb divided by Wa into Mb. This is the formula. I already showed you how to derive the formula. If you remember, you can directly use the formula, or if you do not remember, you can just derive the formula this way. Okay. Now the values will put delta Tf is 0.48. So I am putting 0.48. 1000 into Kf, that is 5.12, into Wb, which we have to calculate, divided by Wa, which is given to us as 75, and Mb is given to us as 256. Okay, Wa is not required, Ma is not required over here, so this should not be required. Okay, so this is the thing. So from here Wb we have to calculate. So I am just rearranging and writing. You can do the calculation. 0.48 into 75 into 256 divided by 1000 into 5.12. So if you calculate this, you should get the answer. So the answer will come 1.8 gram. Please do the calculation and check your answer from here. Let's start with the question number 6. Calculate the boiling point elevation of a solution prepared by adding 10 gram of MgCl2 to 200 gram of water. So very clear that it is 10 gram is the solute and 200 gram is the water. So 10 gram should be denoted by Wb. 10 gram, this is given. Okay, and it is dissolved in Wa, that is weight of solvent is 200 gram here. Assuming MgCl2 is completely dissociated, okay, and Kb is given to us, that is 0.512 Kelvin kg per mole, and molar mass of MgCl2, which is denoted as Mp, molar mass of the solute, is 95 gram per mole, and we have to calculate the boiling point elevation, which means we have to calculate delta Tb is equal to what? This question has come in 2023 for 3 marks. Yeah. So we know the formula, that is, the formula is your elevation in boiling point formula, that is delta Tb is equal to I into Kb into M. And I told you how to break molality, so I will just directly write down I into 1000 into Kb into Wb divided by Wa into Mb. This is the formula. Now we have to find out what's the value of I. So MgCl2 is completely dissociated. So when MgCl2 completely dissociated, it gives you Mg2 plus 2Cl minus. So here we can see I is equal to number of moles of particle after dissociation divided by number of moles of particle before dissociation. So after dissociation we can say it is 2 plus 1, 3, and before dissociation it is 1. So the value of I will be 3 over here. Mg2 plus 2Cl minus. Okay, 3. So now put it here. I is 3 into 1000 into Kb. The value of Kb is 0.512 into Wb, which is 10, divided by Wa, which is 200, into Mb, and Mb is given 95. So calculate this. We have 0, 0, 0, 0, and this is 5, 2, this is 5, 1, 5, 9, 19. So we are getting here, in the numerator we have this 2 and 2 will get cancelled. So in the numerator we have 3 into 10 into 0.512 and divided by we have 19 at the denominator. So if we calculate this, we should get the value of delta TB, 0.80 Kelvin. So this is the value of delta TB. Please do the calculation and get the answer checked. So we'll start with the next question. The question number 7 is the freezing point of solution containing 5 gram of benzoic acid whose molar mass is 122 gram per mole in 35 gram of benzene is depressed by 2.94 Kelvin. What is the percent dissociation of benzoic acid if it forms a dimer in solution? Okay, so basically benzoic acid is forming a dimer, means it is an association. 2 benzoic acid combines together to give you a dimer. Okay, so let's first write down the given information here. The freezing point of solution containing 5 gram of benzoic acid. So this 5 gram is the weight of the solute, which is denoted by Wb, is equal to 5 gram whose molar mass is given. So molar mass of solute denoted by Mb is 122 gram per mole. Now in 35 gram of benzene, which is my Wa weight of solvent, that is 35 gram, is depressed by 0.294 Kelvin. So this is the depression in freezing point delta Tf is equal to 2.94. Sorry, I told the value wrong. It is 2.94 Kelvin. What is the percent dissociation? That means we have to find out alpha percent dissociation of benzoic acid if it forms a dimer in the solution. It is forming a dimer in the solution. So first of all, I'll use the formula, that is the value of Kf is also given. Kf is equal to 4.9 Kelvin kg per mole. Question has come in 2020. So the formula is delta Tf is equal to I into Kf into molality. Okay. Now the value of molality, again we can just break it down. So it will be 1000 into I into Kf into Wb divided by Wa into Mb. This is the formula. So delta Tf is 2.94 is equal to 1000 into I we do not know. Kf is given 4.9, Wb is 5 divided by Wa, which is 35, into Mb, the value of Mb is 122. So from this we can get the value of I. Okay, so I will be is equal to 2.94 into 35 into 122 divided by 1000 into 4.9 into 5. You can do the calculation and get the value of I. I just calculated it. So the value of I comes 0.512. So here the value of I is 0.512. This is the value of I. Now since it is getting associated, the benzoic acid is forming a dimer. So we have to use the formula, that is the relationship between I and alpha. For association, the relationship is I is equal to 1 minus alpha plus alpha upon n. This is the relationship for association, and here n is equal to 2 because it is forming a dimer, means 2 molecules are forming one molecule. It's a dimer. Okay, so the value of n will be 2 over here. So I is equal to 1 minus alpha plus alpha upon 2. So if I calculate this, I minus 1 is equal to, the LCM is 2. This is minus 2 alpha plus alpha. So I minus 1 is equal to minus alpha by 2, or the value of I is 0.512. Minus 1 is equal to minus alpha by 2. So you calculate this, it is 1.00.512. By subtract it, it is coming 0.488. Okay, so minus 0.488 is equal to minus alpha by 2. Minus and minus gets cancelled. Alpha is equal to 0.488 into 2. So it's coming, if I do this, okay, so it is 0.9. So alpha is coming 0.9. That means percentage of alpha will be 90%. Okay, so they are asking for percentage of alpha, which I will be writing as percentage alpha is equal to 0.9 into 100, which is coming 90%. Question number 8. It says that when 25.6 gram of sulfur was dissolved in 1000 gram of benzene, the freezing point is lowered by 0.512 Kelvin. Calculate formula of sulfur. Okay, Kf of benzene is given 5.12 Kelvin per Kelvin kg per mole, and atomic mass of sulfur is given 32 gram per mole. The question has come in 2023 for 2 marks. Okay, let's start with the given quantities first. Given is 25.6 gram of sulfur, which is the weight of sulfur denoted by Wb. 25.6 gram has dissolved in 1000 gram of benzene, so that's Wa, weight of solvent, that's 1000 gram. Okay, the freezing point is lowered by this, so this is delta Tf is equal to 0.512 Kelvin. Kf of benzene is given, that is 5.12. Kf is benzene is 5.12 Kelvin kg per mole. Atomic mass of sulfur is given, that is 32 gram per mole. So we'll use the formula first. Here the formula would be delta Tf is equal to 1000 into Kf into Wb divided by Wa into Mb. Here we can see delta Tf is given, Wb is given, Wa is given. Okay, so from this, and Kf is also given. So from this formula, we'll find out the value of Mb first. So Mb will be 1000 into Kf into Wb divided by Wa into delta Tf. Let's put all the values and get the value of Mb. So this is 1000 into Kf. Kf is given 5.12 into Wb, which is 25.6 divided by Wa, that's your 1000 again, into delta Tf. Delta Tf is 0.512. So if you calculate this, 1000 and 1000 will get cancelled. I'll remove the points. So I'll write 512 upon 100 here to remove the point. This is 512 upon 1000, that 1000 will go up, into 25.6, so that will be 256 upon 10. I just removed all the points, I have taken them in fractions. So 512 gets cancelled. This 0, 0, 0 and 0, 0, 0 gets cancelled. So I get 256 gram per mole. This is the molar mass of the compound. Here the compound is Sx, sulfur. Okay, so molar mass of sulfur is this, and atomic mass of sulfur is 32. It is given to us. So we can write down molar mass of Sx is equal to number of atoms into atomic mass of sulfur. So this is given 256, we got it. So x into, this is 32, it is given to us. So the value of x is equal to 256 upon 32, which is coming 8. Therefore, the molecular formula of the compound, they have given the compound as Sx is equal to S8. We'll just see the question what they are asking. They are asking calculate formula of sulfur. So formula of sulfur is S8. We start with question number 9. It says that determine the osmotic pressure of a solution prepared by dissolving 2.5 into 10 raised to power minus 2 gram of K2SO4 in 2 liter of water at 25 degrees Celsius, assuming that K2SO4 is completely dissociated. R is equal to 0.08 to 1 liter atmosphere, Kelvin inverse, mole inverse. Molar mass of K2SO4 is 174 gram per mole. Question has come in 2013. So let's start with the given quantities again. The given quantities are determine the osmotic pressure, that means they are asking for pi. Osmotic pressure is denoted by pi. Prepared by dissolving 2.5 into 10 raised to power minus 2 grams. So this is your WB. This is the solute dissolving they are saying. Prepared by dissolving. So by the language you have to understand it is a solute of K2SO4 in 2 liter of water. So your volume of water is equal to 2 liter at 25 degrees Celsius. So T is equal to 25 degrees Celsius, which is converted into your Kelvin. To 25 plus 273 will be is equal to 298 Kelvin. In chemistry, you have to always take the temperature in Kelvin, remember, while doing the numericals, okay? Assuming that K2SO4 is completely dissociated, R is equal to given 0.0821 liter atmosphere Kelvin inverse mole inverse is the value of R, and molar mass of K2SO4 is given 174 gram per mole. Okay. Now they are saying assuming complete dissociation of K2SO4. So when K2SO4 is dissociated, K2SO4 completely dissociates to give you 2K plus and SO4 2 minus. So what is I? I is equal to number of ions formed after the dissociation divided by number of ions, number of moles of the number of particles before dissociation. So number of particles after dissociation is 2 plus 1, that is 3, and before dissociation it is 1, so the value of I is 3. So here pi is equal to I into CRT. This formula we are going to use, where C is equal to concentration and concentration is equal to number of moles divided by volume of solution. So it is NB by Vs into RT. Now NB can be written as WB by MB into Vs into R into T. So we have all the values. Now we will just put the values here. So I'll do it in the next page. Pi is equal to I into NB divided by MB. NB divided by MB into Vs into R into T. This is the formula we got. We'll just check it. Yes, a WB by MB into Vs into R into T. So now we have the values. I is equal to 3. NB, number of moles we don't have, so WB by MB we will do. MB is how much? It is 174. WB is 2.5 into 10 raised to power minus 2. So WB, oh sorry, this is not MB, this is WB. This is WB, weight upon moles is equal to weight upon molar mass, okay? So WB is 2.5 into 10 raised to power minus 2. MB is given 174. R is given 0.0821. Temperature is 298 Kelvin divided by Vs, that is 2 liter. So when we calculate, so it is 5.27 into 10 raised to power minus 3 ATM atmosphere. Pi is equal to 5.27 into 10 raised to power minus 3 atmosphere. Here R is given in atmosphere, so we got the value in atmosphere. We start with question number 10 now. When 19.5 gram of FCH2COOH, whose molar mass is given 78 gram per mole, is dissolved in 500 gram of water. So we understand that this is the solute, okay, and 500 gram, that's the solvent. The freezing point depression is observed to be 1 degree Celsius. Calculate the degree of dissociation of the solute. Kf of water is given, and the question has come in 2023 for 3 marks, okay. So first we write down the given quantities. First thing what is given is when 19.5 gram, that's the weight of the solute. that's 19.5. I feel that you know the denotation now for everything. So weight of the solute, that is WB, we should write like this. Molar mass of the solute, that is MB, that is 78 gram per mole, is dissolved in 500 gram of water, which is the weight of the solvent WA, that's 500 gram of water. The depression in freezing point is observed to be 1 degree Celsius, so that's delta TF is equal to 1 degree Celsius. Calculate the degree of dissociation, that is alpha is equal to what you have to find out of the solute, and Kf of water is given. Kf of water is equal to 1.86 Kelvin kg per mole. This is a Kf of the solution, and yeah, so the question has come in 2023 as I told. So from here we'll use the formula, that is delta TF is equal to I into Kf into M. Now this should be broken down, I into Kf into 1000 into WB divided by WA into MB. So from here delta TF is 1, this is delta TF. I we do not know, I will find out from here. Kf is 1.86 into 1000, WB is 19.5 divided by WA, which is given 500 into MB is given 78. So from here I is equal to 500 into 78 divided by 1.86 into 1000 into 19.5. So this 0 0 gets cancelled, 0 0, this is 5, this is 2, and this is 2 3 2 9 39. Okay, so it's 39 divided by 1.86 into 19.5. If you calculate this, you will get the value of I, and we have the value of I here is 1.0753. 1.0753. This is the value of I. And now since it is dissociated, okay, FCH2COOH is dissociated, we'll see how the dissociation is done. FCH2COOH. Clearly it is an acid, so it will dissociate it as FCH2COO minus and H plus. Since it is an acid, it will be liberating H plus. So from here we can see I is equal to 1 plus 1, 2 divided by 1, that is 2. Now we are going to use a formula, the relationship between I and alpha. So for dissociation, the relationship is I is equal to 1 plus n minus 1 into alpha. This is the relationship. Okay, so here I is equal to 1 plus n is equal to 2 here. 1 plus 1, 2. 2 minus 1 into alpha. So I is equal to 1 plus alpha. I is 1.0753 minus 1 is equal to alpha. So alpha is equal to 0.0753. Okay, we subtract this and get the answer. So here we have to leave the answer in percentage alpha. So percentage alpha is equal to, percentage alpha is equal to 100 into 0.0753. So it is almost 7.53%. So this is the answer for this question. So the next question is, a 5% solution by mass of cane sugar, molecular mass is 342 gram per mole, is isotonic with 0.877% solution of substance X. Find molecular weight of X. Question has come in 2015 for 3 marks. So when we say isotonic, the meaning of isotonic, iso is same, tonic is concentration. And we know that for same concentration of solution, the osmotic pressures are same. Okay. So here 5% solution by mass of cane sugar. So we'll take WB as 5 gram and MB of cane sugar is 342 gram per mole. Is isotonic with 0.77% solution of the substance. So it is the weight of the substance X is equal to 0.877 gram and MB, that is Mx of the substance, we do not know. Find the molecular mass only, we have to find out. Since they are isotonic solutions, so we'll write for isotonic solution. For isotonic solution, we know that pi 1 is equal to pi 2. That is osmotic pressure for this will be equal to osmotic pressure for that. So pi is equal to C1 into RT will be equal to C2 into RT. RT is same for both of them, so it will be C1 is equal to C2. Concentrations are same. Concentrations are same means N1 upon V will be equal to N2 upon V. Okay, the concentration is number of moles upon volume. Again the V are same number of, same volume of solution, so N1 will be equal to N2. Now here number of moles are equal. Number of moles are basically W1 upon M1 should be equal to W2 upon M2. So here W1 means this one. Okay, so we take 5 and M1 means this one. So that is 342. W2 we have 0.877 and M2 that is we have to find out MX ka value. Now from here cross multiply 5 into MX will be equal to 342 into 0.877. So the value of MX is equal to 342 into 0.877 divided by 5. So when you calculate this, you get the answer for molecular weight of the substance, and I have that is 60 gram per mole. So when you calculate this, we get the answer as 60 gram per mole. Please do the calculation and check your answer. Next question, that is question number 12. 45 gram of ethylene glycol is mixed with 600 gram of water. So when you see the weights, you understand that ethylene glycol is a solute here and water is the solvent here. So I am writing the given condition. 45 gram of ethylene glycol, that is WB, is equal to 45 gram is mixed with 600 gram of water, that is WA, is equal to 600 gram. Calculate the freezing point depression. So you need to find out delta TF is equal to what, and also the freezing point of the solution. That means you have to find out TF. Freezing point of solution is what? These are the two things. First is delta TF and second part you have to find out is TF of the solution, freezing point of the solution. What is given to us is KF is given to us, that is 1.86 Kelvin kg per mole. What else is given? Yeah, so that is it. So now we have delta TF is equal to KF into M. Now, ethylene glycol is not an electrolyte, so we'll write only Kf into M. Delta Tf we have to find out. Kf is 1.86. M will break down 1000 into Wb divided by Wa into Mb. So it is 1.86 into 1000 into Wb. Wb is my 45. Wa that's given 600 into Mb. Mb is your, we have to find out the Mb from here. So it is C2H6O2. So M of C2H6O2. C2 means it is 12 into 2 plus 6 into 1 plus 2 into 16. So that's 24 plus 6 plus 32. 24 plus 6 is 30 plus 32. Sorry, this is plus 30 plus 32. So that is 262 gram per mole. Okay, so here we have the Mb, that is 62 gram per mole. So if you calculate this, you can cancel 0, 0, 0, 0. You can cancel this by 3, 3, 2, and then 3, 1, 3, 5. And then you can cancel this and this. This will be 5. So we have 1.86 into 5 into 15, that's 75 divided by 62. If you calculate this, we get the value of delta TF, and we have the value of delta TF, that is 2.25 Kelvin. 2.25 Kelvin. This is the value of delta TF. So the first answer we got. Now TF we have to find out. So for TF we know that it is delta TF, it is freezing point depression. That means depression in freezing point is equal to the solution's freezing point will be depressed. That means it is a pure freezing point of the solvent minus freezing point of the solution. So freezing point of the solution will be pure freezing point of the solvent minus delta TF. I rearrange this I got this side and this I got that side. Now since it is water, pure freezing point of water is 0 degrees Celsius. So 0 degrees Celsius and delta TF we got as 2.52 Kelvin. So 0 degrees Celsius is 273 Kelvin minus this is your the previous answer we got as 2.52 Kelvin, sorry, the previous one 2.52 Kelvin, 2.25 Kelvin. Okay, so it will be 2.25, so it is 273 minus 2.25. So when you do the calculation, you get, so the answer is coming 270.9 Kelvin. So this is the answer for this question. Question number 13 says 1 molar aqueous solution of trichloroacetic acid, the formula is given, is heated to its boiling point. The solution has a boiling point of 100.18 degrees Celsius. Determine Van't-Hoff factor of CCl3COH Kb is given to us. The question has come in 2012 for 3 marks. So given quantities, first we'll write down 1 molar. So here molarity is equal to 1 molar. Aqueous solution of trichloroacetic acid is heated to its boiling point. The solution has a boiling point of 100.18. This is a boiling point of the solution, that is TB, 100.18 degrees Celsius. Determine Van't-Hoff factor. So I we have to find out for this, and the value of Kb is given 0.512 Kelvin kg per mole. So we'll use the formula over here, that is delta TB is equal to I into Kb into M. This formula we are going to use. It's an aqueous solution, so here TB will be is equal to T naught B, that is boiling point of water, will be is equal to 100 degrees Celsius. Okay, so delta TB will be is equal to TB minus T naught B. So that is 100.18 degree minus 100. So that will give you 0.18 degrees Celsius. We know that the delta TB in degrees Celsius and in Kelvin is same. So it will be 0.18 Kelvin only. Here we can take that as a value of Kelvin as well, because the difference is always, difference comes same. Okay, so here I is equal to, we do not know, delta TB we got. So we'll put the value of delta TB here, that is 0.18. I we do not know, they are asking for I. Kb is given 0.512 and molality is also given. So from here I will be is equal to 0.18 divided by 0.512. If you do this calculation, we get the value of I, and here the value of I is coming 0.35. So it is 0.35. Question number 14 is, calculate the boiling point of solution when 4 gram of MgSO4, molar mass is 120 gram per mole, was dissolved in 100 gram of water, assuming MgSO4 undergoes complete dissociation. The question has come in 2015 for 5 marks. So the given quantities first, calculate the boiling point of solution. So that means we have to find out TB. Boiling point of solution is denoted by TB. When 4 gram of MgSO4, MgSO4 is a solute over here. So the weight of solute is denoted by Wb, which is 4 gram, and the molar mass of solute is denoted by Mb, which is 120 gram per mole. This is dissolved in 100 gram of water, which is the weight of the solvent, that's 100 gram, and assuming that MgSO4 undergoes complete dissociation. So MgSO4, when it dissociates completely, we have Mg2 plus ions and SO4 2 minus ions. So here I is equal to particles after dissociation, that is 2, divided by number of particles before dissociation, that is 1. So the value of I is 2 here. So we have the formula, that is delta TB is equal to I into Kb into molarity of the solution. Okay, so now TB of the solution we should get, and this is aqueous solution dissolved in water. So the value of Kb should be given to us. The value of Kb here is given, that is 0.512. I forgot to write it in the question. So I am just writing it here. Kb is equal to 0.512 Kelvin kg per mole. This will be given to. Okay. So now delta TB is equal to TB minus T naught B is equal to I, that is 2, into Kb, that is 5.12, into molarity of the solution. Molarity of the solution will be 1000 into Wb, Wb is 4, divided by Wa, that's 100, into Mb, Mb is 120. I wrote it now in one step because we have done it many times. So from here TB we do not know, and del T naught B, that is the boiling point of water, which is taken as 273 Kelvin. From here we can calculate this 0 0 0 0 cancel, this 0 and this 0 cancel, 4, this is 3, and yeah, so that's it. So 2 into 5.12, 2 into 5.12 divided by 3. So from here TB will be is equal to 2 into 5.12 divided by 3 plus 273. So when you calculate this, you get the answer. So it is 373.496 Kelvin. Please do the calculation and get your answer checked. So let's proceed towards the next question. Question number 15. It says that the vapor pressure of pure liquid A and B are 450 and 700 mm of Hg at 350 Kelvin respectively. Find out the composition of the liquid mixture. If total vapor pressure is 600 mm of Hg, find the composition of the vapor phase as well. The question has come in 2017 and it was of 5 marks. So first we'll write down the given information. The vapor pressure of pure liquid A, which is denoted by P naught A, which is 450 mm of Hg, and the vapor pressure of pure liquid B, which is denoted by P naught B, that's 700 mm of Hg, and the total vapor pressure, that is Pt, is equal to 600 mm of Hg. So we know that total vapor pressure is equal to partial pressure of A plus partial pressure of B. This is according to Dalton's law. Now partial pressure of A is equal to P naught A into XA plus P naught B into XB. This is as per Raoult's law. Now what we'll do is, we know that XA plus XB is equal to 1. So what we'll do is here P naught A XA, in place of XA I'm going to write 1 minus XB plus P naught B into XB. Why did we write it? Because we know XA plus XB is equal to 1. So in place of XA I am writing 1 minus XB. Now let's put the values, see what it is coming. PT is 600 is equal to P naught A, which is 450 into 1 minus XB plus P naught B, that's 700 into XB. Now I'll multiply this, I'll get 600 is equal to 450 minus 450 XB plus 700 XB. So I'll get 450 this side, 600 minus 450 is equal to, I'll take XB common from here, so it will be 700 minus 450. So 450 and 600, this subtraction will give result to 150, and this is XB into, this is 250. So XB would be is equal to 150 upon 250, 0 0 cancel, 5 3 5 5, 3 upon 5, that is 0.6. So we got the mole fraction of B, that is 0.6. So XA would be equal to 1 minus XB, that is 1 minus 0.6, which will give rise to 0.4. So I got the mole fraction of A and B in the liquid state. Now we have to find out the composition of the vapor state. Composition of the vapor state is denoted by Y. YA is equal to PA upon PT and YB is equal to PB upon PT. For YB we can also use, also we know YA plus YB is equal to 1. So once we get the value of YA, we can even use this formula to get the value of YB. So let's find out. PA is how much? In the previous part you can see PA is P naught A XA. Okay, P naught A XA. So PA is equal to P naught A into XA divided by PT. P naught A, the value of P naught A is 450. So we'll write it here 450 into XA. The value of XA we got, XA is 0.4. So we'll put it here 0.4 upon 600. You can calculate this, 0 0 cancel. 15, 3, 15, 4, 4, and this is 0.1. So it's coming 0.3. So now this formula also we can use. YB is equal to Y minus 1 minus YA, that is 1 minus 0.3, that is 0.7. Or you can use this formula also. PB is what? P naught B into XB divided by PT. P naught B we had 700, XB is 0.6 divided by this is 600, 0, 0, 0, 0 cancel. This is 0.1, so we can get 0.7. So this is the composition of the paper state, that is 0.3 and 0.7. Question number 16 is, why is the value of Van 't Hoff factor of ethanoic acid in benzene is close to 0.5? This question has come in 2023. So we know that, here we should write, we know that ethanoic acid dimerizes in benzene. That means what happens is, two molecules of ethanoic acid, when it is dissolved in benzene, it converts into CH3COOH the whole twice. Two molecules converts into one, it dimerizes. Okay, so I is equal to number of particles after or before association, after association or dissociation. Number of particles after association or dissociation, in this case it is association, divided by number of particles before dissociation. That is my Van 't Hoff factor, which is denoted by I. So here it is number of particles after dissociation divided by number of particles before association. In this case it is association. So we have to write association. This is also association. So after association we have only one, and before association we had 2, so 1 by 2 means it is 0.5. So that is how the Van 't Hoff factor is 0.5 for ethanoic acid in benzene. We'll see the next question. A 0.01 molar aqueous solution of AlCl3 freezes at minus 0.068 degrees Celsius. Calculate percentage of dissociation Kf of water is given. This question has come in 2020. So the molarity is given. So here small m is equal to 0.01 molar. These are the given quantities I am writing. Okay, aqueous AlCl3 freezes at this much. So that is the freezing point of the solution, which is denoted by Tf is equal to minus 0.068 degrees Celsius. It's an aqueous solution, so T naught F is equal to 0 degrees Celsius. That is my T naught F. It is aqueous solution, so freezing point of water we have to take. Calculate the percentage of dissociation, that means percentage of alpha we have to find out. What else is given? Kf of water is given 1.86 Kelvin kg per mole. So we know the formula, that is delta Tf is equal to I into Kf into small m. It is AlCl3. So when AlCl3 dissociates, we get AlCl3 dissociates, we get Al3 plus 3Cl minus. So here I is equal to 3 plus 1, 4 particles divided by 1. So I is equal to 4 we are getting. So we put it in the formula delta Tf. Now delta Tf what? It is freezing point depression. That means the solution's freezing point gets depressed. So if delta Tf is equal to, we will write T naught F minus Tf. That's your delta Tf. That is equal to I into Kf, that is 1.86 into 0.01. From here we'll get the value of I first. This is T naught F is your 0 degrees centigrade minus 0.068 is equal to I into 1.86 into 0.01. So from here we get I is equal to 0.068 divided by 1.86 into 0.01. We have to calculate this value to get the value of S. I calculated the value of I comes 3.65 here. Now since it is dissociation, we have to use a formula for dissociation. the relationship between I and alpha, that is I is equal to 1 minus n minus 1 into alpha. The formula is 1 plus n minus 1 into alpha. Okay, so I here is 3.65, which we got. 1 plus n here is 4 minus 1 into alpha. 4 I showed you in the previous slide. How come it is 4? Yeah, so here it is 4 and I is 3.65. Okay, so 3.65 is 1 plus. So here you are getting 3.65 is equal to 1 plus 3 into alpha. So 3.65 minus 1 is equal to thrice of alpha. So 2.65 is equal to thrice of alpha, or alpha is equal to 2.65 divided by 3. Therefore, percentage alpha is equal to 2.65 divided by 3 into 100%. Now you just multiply this, it will be coming 265 divided by 3. So that is around 8.33%. So this is the value of alpha. We'll start with the next question. That's question number 18, which says a solution containing 15 gram of urea. So I'm directly writing the given quantities. Now you are, like we have done a lot of sums, so you know 15 gram is the weight of solute, which is denoted by WB. Molar mass of solute, which is given to you, that is 60 gram per mole. Okay, a solution containing 15 gram of urea, molar mass is given per liter of solution in water, has same osmotic pressure as a solution of glucose. So next one is glucose, whose molar mass you can write it as mg. We can write for this glucose molar mass, mg is equal to 180 gram per mole. This is given, and calculate mass of glucose present. So we can write it as Wg is equal to what in 1 liter of the solution. Since they are having the same osmotic pressure, so pi 1 is equal to pi 2. Pi 1 is written as C1 RT is equal to C2 into RT. Here RT will get cancelled. So C1 is equal to C2. The concentrations are seen. C1 is equal to C2. C1 is equal to C2. Now C1 can be written as N1 upon V is equal to, this is N2 upon V. Again, the volume of the solution is same because it is per liter, and here also it is 1 liter. So VV will get cancelled and we are getting N1 is equal to N2. Now number of moles are equal. Number of moles is equal to WB, that is weight divided by molar mass, and here it is weight divided by molar mass. We have all the values. WB is 15, molar mass of this is 60, and Wg we do not know, molar mass is given 180. Cross multiply, so we are getting 60 into Wg is equal to 15 into 180. So Wg is equal to 15 into 180 divided by 60. You can cancel it out, 0 and this, 6 and 3. So this is coming 45 grams. So Wg is equal to 45 grams. So weight of glucose is coming 45 grams. This question has come in 2014. So we start with the 19th question now, which says a solution prepared by dissolving 1.25 gram of oil of wintergreen, which is methyl salicylate, in 99 gram of benzene has a boiling point 80.31 degrees Celsius. This is the boiling point of the solution. Determine molar mass of this compound, where the boiling point of benzene is given 80.10 and Kb of benzene is given, and the question has come in 2010. So first of all, we'll write down the given information. First thing is dissolving 1.25 gram of methyl salicylate, which is your WB. This is 1.25 gram, and it is dissolved in 99 gram of benzene, which is your WA, 99 gram, has a boiling point. This is a boiling point of the solution denoted by TB, which is 80.31 degrees Celsius. Determine the molar mass of this compound, so we have to find out the molar mass of the solute. Boiling point of benzene, which is T0B, is equal to 80.10 degrees Celsius, and Kb of benzene is 2.53 degrees Celsius and kg per mole. So these things are given to us. We have to find out the molar mass. So first of all, we will write a formula. Delta TB is equal to Kb into M, and M is 1000 into WB divided by WA, into MB. And delta TB is what? Boiling point elevation, that is boiling point of the solution minus boiling point of the pure solvent, that is your delta T. Okay, this is equal to KB into 1000 into WB divided by WA into MB. Now TB is given to us, TB is 80.31, so we'll put it here, 80.31 minus 80.10 is our T0B. We don't have to convert them into degree Kelvin, because as I mentioned, the difference in degree Kelvin and Kelvin is the same thing. Sorry, degree Celsius and the Kelvin is the same thing. If you do not convert this into Kelvin, it's okay, because when you take the difference in degree Celsius and the Kelvin is the same value. So you don't worry, when you take the difference, it's fine. So we are not converting this into Kelvin. KB is 2.53 into 1000 into WB. WB is your 1.25 and this is divided by WA, that's 99 into MB. So you have to find out MB, so get MB this side. So once I get MB this side and I take this that side, the other side, so it is 2.53 into 1000 into 1.25 divided by 80.31.10. So it is coming 0.21. If you do the subtraction, 80.31 and 80.10, so it is 0.21. Yeah. So 0.21 is the answer. So when you calculate this, you get the answer for MB in gram per mole. They are asking for the determine the molar mass of this compound. I have the answer. I'll just find out. I'll see the answer and write it over there. You can check. So here the answer is 152. Sorry. 152 gram per mole. Question number 20. What would be Van 't Hoff factor if 0.711 molar aqueous solution of Na2SO4 freezes at minus 0.320 degrees Celsius? Kf of water is given. The question has come in 2009. So what all things are given to us? Given is what would be the Van 't Hoff factor? They are asking for I. 0.711 molar. So here molarity is given to us, 0.711 molar. Aqueous solution of Na2SO4 freezes at this. So this is a freezing point of the solution. Tf is equal to minus 0.320 degrees Celsius. It is aqueous solution, that means freezing point of water T0F will be is equal to 0 degree Celsius. And what else is given? Kf, that is 1.86 Kelvin kg per mole. So we know the formula, that is the formula is delta Tf is equal to I into Kf into M. Now what is delta Tf? It is freezing point depression. That means the solution, the freezing point of the solution will get depressed. So delta Tf will be T0F minus Tf is equal to I into Kf into M. So T0F is 0 degrees Celsius, we'll put it here, 0 minus Tf is minus 0.320 is equal to I, we do not know, Kf is 1.86 and molarity is 0.711. So from here we can calculate this. This is your 0.320 is equal to I into 1.86 into 0.711. So from here I will be is equal to 0.320 divided by 1.86 into 0.711. So if you calculate this, we get the value of I. I have the value. So here I comes 2.4. You can check your calculation and get your answer checked from here. So now we start with question number 21, which says boiling point of water at 750 mm of Hg pressure is 99.68 degrees Celsius. It is the boiling point of water, that means it is pure, the boiling point of the pure solvent, which is denoted by T0B, is equal to 99.68 degrees Celsius. How much sucrose, that is of molar mass 342 gram per mole. MB is given to you 342 gram per mole. How much sucrose, how much means they are asking for WB, is to be added to 500 gram, which is my WA is 500 gram. such that it boils at, that means the solution boils at 100 degrees Celsius, and the Kb is given to us 0.52 Kelvin kg per mole. So first of all, we are going to write down the formula. The formula is, sucrose is non-electrolyte, we know. So delta Tb is equal to Kb into small m 1000 into Wb divided by Wa into Mb. This is the formula. Boiling point elevation, that means the boiling point of the solution is mode. So it is Tb minus T0b is equal to Kb into 1000 into Wb divided by Wa into Mb. Now here Tb is equal to 100, so I'll put it 100 here, minus 99.68 is equal to 0.52 is my Kb into 1000 into Wb is asked. Wa is 500 and Mb, which is given 342. So this is 0.32 is equal to 0.52 into 1000 into Wb divided by 500 into 342. 0, 0, 0, 0 cancel. This is 5, 2. This and this will get cancelled. 3, 1, 2, 3, 1, 171 it is. So 171 into 0.32. Sorry. Wb is equal to 171 into 0.32 divided by what will come? 0.52. Yeah, so that's it. 0.52 divided by 0.52. So if you calculate this, we get the answer. I am getting the answer as 105.23 gram. So you just calculate this and see the answer, get it checked here, from here. So we have almost come to the last part of this video. Now the two sums are remaining. So the 22nd sum is the vapor pressure of a solvent at 283 Kelvin is 100 millimeter of Hg. So I am directly writing now. It is a vapor pressure of the solvent which is denoted by P0 A is equal to 100 millimeter of Hg. Calculate the vapor pressure of the dilute solution Pa we have to calculate, containing 1 mole of the strong electrolyte. So number of moles of the electrolyte is 1 mole, and Ab in 50 moles of the solvent. So Na is equal to 50 moles it is given, and at 283 Kelvin the temperature remains constant. Assume complete dissociation of Ab. We have to consider Ab is completely dissociated, that means Ab dissociates to give you A plus and B minus. From here we can see I is equal to number of particles after dissociation, which is 2, divided by number of particles before dissociation, which is 1. So it is 2. I is 2. Now we are going to use the formula, that is relative lowering of vapor pressure P0 A minus Pa upon P0 A. This is relative lowering of vapor pressure is equal to I into Xb. I into Xb, and Xb is Nb divided by Na plus Nb. Now we know that for a dilute solution, Na plus Nb is almost equal to Na, because as compared to Na, Nb, the value of Nb will be very, very less, very, very small, and that is why we can ignore the value of Nb. So finally the formula reduces to P0 A minus Pa upon P0 A is equal to I into Nb divided by Na. Now we put all the values. P0 A is 100 minus Pa we need to find out. P0 A is again 100 here. I is 2 into Nb, which is 1, and Na, which is 50. So here it will be cancel out to 1 upon 25 we are getting. Now we will cross multiply. So we are getting 25 whole into 100 minus Pa is equal to 100. I'll just see the previous slide. 25 into 100 minus Pa is equal to 100. 25 minus 100 into 100 minus Pa is equal to 100. So it is 2500 minus 25 Pa is equal to 100. So minus 25 Pa would be 100 minus 2500. I rearranged, I got 2500 that side. So it is minus 2400 minus 25 Pa is equal to, where minus and minus gets cancelled. So Pa would be is equal to 2400 divided by 25. We can cancel it out with 5. So it is 5, 5, 5, 4, 8 and 0. and then 5 96. So PA is equal to 96 millimeter of Hg. Is it correct? Yes, 96 millimeter of Hg. Now this is the last question of this video. Calculate the mass of CaCl2. Mass of CaCl2 means they are asking to calculate Wb is equal to what? Molar mass of CaCl2 is given 111 gram per mole to be dissolved in 500 gram of water. That's your Wa is 500 gram. To lower its freezing point by 2K, so that is your delta Tf is equal to 2K. Assuming CaCl2 undergo complete dissociation and Kf is equal to 1.86 Kelvin kg per mole. Okay, and CaCl2 undergoes complete dissociation, that means CaCl2 is giving you Ca2 plus 2Cl minus. In this case, I is equal to 2 plus 1, 3 divided by 1, that is 3. Here we use the formula. The formula is equal to delta Tf is equal to I into Kf into molarity. We break down molarity, so that is 1000 into Wb divided by Wa into Mb. This is the formula. So delta Tf is directly given to you 2. I is equal to 3 into Kf, which is 1.86 into 1000. Wb we need to find out. Wa is been given to us, that is 500 into Mb, and Mb is also given to us, that is 111. So from here, after rearrangement, we get Wb is equal to 2 into 500 into 111 divided by 3 into 1.86 into 1000. So when you calculate, you get the answer. I've already calculated it before, and the answer is coming 19.98 gram. So it is 19.98 gram. You please do your calculation and check the answer from here. Okay, so in this video we have completed all the PYQs of solution chapter right from 2009 to 2024. In 2025 also you will be getting the sums like this only, so practice it well and you will be thoroughly done with the numericals of solution. Thank you so much. If you feel these videos are beneficial to you, please subscribe the channel and press the like button. Thank you. Stay tuned.